Hi, it's Zen with another video, and this time I will be doing a rebuild series on the BMW's N43 engine, and that's because I bought a car that had some engine issues, and when I started diagnosing the issue it turned out that there were plenty of VANOS codes, low oil pressure codes, and it would crank but it would not start or run. So I removed the oil filter and it turned out that it was full of bearing material. So you can see these copper particles, and also the filter itself was totally destroyed and it had holes inside. So I knew that the issue was pretty serious. Then I removed the valve cover and inspected the top part of the cylinder head. And when I removed the camshafts, I did find out that they are pretty scorned on the journals. So this definitely catches the fingernail. And also the camshaft bearing cups are pretty scorned up. So this can also be felt by the fingernail. And so the next step was to remove the engine from the car and do a full teardown. And the first thing that I found after pulling the oil pan was plenty of plastic pieces inside the oil pan, and when I removed the oil pickup I found out that the whole mesh inside of the pickup was clogged with these little plastic pieces. So these are the pieces from a broken chainrail guide, and this is what caused the oil starvation. After removing the balancing shaft unit and the oil pump, I was able to get to the crankshaft and the conrods, and I immediately knew that something was wrong. The conrod shells were discolorated, which means that there was plenty of heat inside, and I could actually feel play on the conrods. So when I removed them, I found that 3 of the 4 bearings on the conrods had spun, and this is the result, and this is what caused all of that bearing material inside of the engine. I have a pretty detailed videos on all of this, so I have a video on how I diagnosed this issue. I have a video on how I pulled the engine out of the BMW 1 Series, and I also have a separate video on the teardown, and there's plenty of information there. If you are interested, check it down in the description and up in the cards. So at this point I realized I'm going to need a new engine for this car, and when I started looking for one I realized that they are quite rare and quite expensive, so it would cost me almost as much as this car did. So that was definitely not the way I wanted to go about this thing. After the teardown, I know that I have a good engine block, and I think I can save the cylinder head and the camshafts. However, I will definitely have to replace the crankshaft and the conrods. The conrod pins are totally destroyed and quite a lot of material is missing, so I don't think it's economical to repair this crankshaft. And also the conrods are most probably out of shape. You know, this is a critical component, so I don't want to reuse this. This engine has 216,000 kilometers on the clock, and I think it's worth rebuilding and give it another 100 or 150 or maybe even 200,000 kilometers. To be honest, it's still probably not economical to rebuild an engine like this. It's best to get a good working used engine and just replace it in the car. But you know, I like some challenges from time to time, so I've decided to rebuild it. I'm not sure what the results will be. I will give it my best, and let's get into this rebuild series. I'm going to be rebuilding the bottom end first, and that's gonna be the part 1. And then I'm going to rebuild the cylinder head, and that's gonna be the part 2. And in the part 3 I'm going to put everything together and do the timing on the engine. Now let's talk about sourcing parts for this kind of build. The BMW's N43 engines come in different varieties, so you have the B20 version, that's the 2 liter, and then you have the B16, that's 1.6 liter version. And on the B20 you have 3 power levels, so you have the 122, 143 and 170 horsepower for the strongest version. All B20 engines are basically the same engine. The only exception is that on the strongest model, 170 horsepower version, there's a different intake camshaft with longer lift on the valves, and there's also a variable intake length manifold, so that gives it a bit more power. But on the 122 and 143 HP power versions, the engine is identical. The only difference is with the ECU tuning. So that means that you can use components from whichever B20 model you want. So you can reuse the crankshaft, you can reuse the pistons, the conrods, and all of the components, except of course the intake manifold and the intake camshaft, because it is a bit different. Another option would be to use crankshaft and the conrods from N42 or N46 engine, and that's because it shares the same platform, it has the same geometry, so it has the same crankshaft and the conrods. Actually, the part numbers are identical. So if you can find the good bottom end from those engines, you can go ahead and use that. Just make sure that it's the same B20 model with the same displacement. When I was looking on the internet for a used replacement engine, I came across an ad for this engine here. This is the N43 170 horsepower version, and it stated that it's a complete engine, but there was some malfunction and the engine is disassembled. Just come here and get it, and that's exactly what I did. So I drove there, I took my tools with me, and I took the engine apart even further, and I inspected it, and I realized that it still had a good bottom end. So the crankshaft is still usable, the pistons are still usable, the conrods are still usable, none of the bearings showed any major signs of damage. And when I did some further investigation into this engine, I found out that also here the plastic chainrail guide broke and the chain jumped so severely that the pistons hit the intake valves, and when that happened, the intake camshaft kind of broke all of the bearing shells. I couldn't even find the rest of the bearing shells, I only have number one, and you can see how this looks like. Another thing that happened is that the oil pump actually broke during this impact. And yeah, this is another proof that you really need to replace this plastic chainrail guide, or you risk destroying your engine. Sadly, I cannot reuse this block because the owner put it under a barn and it got wet a lot, and there's a lot of corrosion on the cylinder walls, so I think that that cannot be just honed out. It needs to be rebored, and you have to use larger pistons for that, so I just don't want to deal with all of this stuff. Here's the crankshaft from this used engine. As you can see, all of the journals are pretty smooth and shiny, so almost a mirror finish. So this engine had about 120,000 kilometers on the clock, and there are just some minor signs of wear, but nothing too dramatic. Also, the bearing shells on the conrods and the mains were in pretty good condition, so no damage there. Also, the conrods seem to be in good condition, nothing looks overheated. I did notice that the piston rings here are pretty gunked up, and they're definitely stuck. At least the top two piston rings are definitely stuck. They cannot be rotated. So this is what stuck piston rings look like. Anyway, I'm going to reuse these conrods. Since I have a pretty good cylinder block, and this is the low power version with 122 horsepower, I've decided not to hone the cylinder walls and just let it be. And that means I have to reuse the pistons and the piston rings because they are mated to the cylinder they are running in. And I will only be swapping the conrods from the donor engine to this engine. If you decide to hone the cylinder walls, then you also have to replace the piston rings and do the proper break-in procedure. I will not do that in this case because I'm doing this on a budget and I don't want to work on this engine for another month. So I think it's gonna be fine. So the first thing I want to do is just clean this piston, and as you can see there's a lot of carbon here, and also on the inside there are some oil deposits. So the easiest way to do that is to just use a very strong degreaser and heat it up and just let it do its magic. Here's my incredibly Slav setup. So I'm using this old wood burning stove to heat up this metal mug, and I've put some universal degreaser inside. I usually use this Melio degreaser. It's pretty cheap and it works wonders. So now it's getting nice and hot, and I will just put the piston in. Extremely satisfying. And I'm going to leave it like this for like 15 minutes and take it out and use a toothbrush and just scrape off the major deposits that are left. And after half an hour or 45 minutes, the piston comes out pretty clean. So it's been cooking nicely for 15 minutes. Let's check the results. Oh yeah, spot the difference. So as you can see, it's pretty clean already. Yeah, it brushes right off. Here it is after another 15 minutes, and as you can see the carbon is completely gone and we have a nice clean piston. I'm also going to rotate the piston rings. This way I can agitate some more of the dirt. I just want to scrape as much dirt as I can. The piston is now clean enough so I can work on it, and the next thing I have to do is remove one of these circlip that holds the gudgeon pin to the piston and the conrod, and this way I can tap it out and remove the conrod. To remove this circlip I'm going to use a small flat screwdriver, and I'm going to use this hole here to grab the ring and gently pry it out, and with my other hand I'm going to make sure that the clip doesn't fly somewhere in the garage. So wear eye protection. Now I should be able to remove the gudgeon pin. Now in theory this should be possible by hand. So if I just press it here on this side, I can feel it slide, but it could be a little bit stuck. So I'm going to use a little bit of force here. Just a slight tapping should suffice. I can feel it sliding out. I'm going to use a little bit of WD-40 to make sure that everything is nice and lubricated. Almost there. And it's out. Here's the old conrod. This can now be an interesting Christmas ornament. I'm going to clean the surface a little bit. And I'm going to put the gudgeon pin back. Now I'm going to carefully remove the top piston ring. There are special pliers for this. I don't actually have them, so I'm just gonna do it by hand, and I'm going to be extra careful. So I just have to guide the piston ring out and just rotate it at this point. And it's out. So I can see that there is a little bit of deposits on the ring. So I'm going to put it back into the degreaser. Now comes the second ring. Here's the second ring. Now for the oil scraper ring. The oil scraper ring is made out of 3 separate rings. So the top and the bottom rings, and then there's the middle ring. And now I have to find the separation here. So it just opens up and it's out. So there is still a little bit of debris in the piston ring channels, so I'm going to put this piston back in the degreaser bath and clean everything out. I'm going to use a little piece of zip tie that is cut at an angle and manually clean the channels. So I'm just gonna scrape all of this dirt out, and it's pretty effective. And you can't do any damage here. Now I'm going to measure the clearances on the piston rings. So according to the specifications, on the piston ring number 1, that's the top one, there should be an end clearance of 0.15 to 0.30. So I have my feeler gauge here. Yeah, it's pretty old school. I'm going to show you how to measure this on the cylinder number 4, but obviously I have to do this on all 4 cylinders. First, I'm going to oil up the cylinder wall, and I'm also going to make sure that it's nice and clean. Now I'm going to put in the piston ring, and I'm going to make sure that it's oriented correctly. So the marking must be at the top. Now I'm going to use the caliper and set it to 20 millimeters. And I'm going to make sure that the piston ring is evenly spaced from the top of the engine block. So I'm just going to push it down a little bit. I'm going to make sure that it's nice and even. First, I'm going to try the biggest gap. So this is the 0.3. And it looks like I can't insert this one. So let's go a size lower, the 2.5. And this one I can just about insert. So the end gap on this top piston ring is 0.25. Now I'm going to do the same on the second piston ring. The second ring measured to a 0.45 gap, which is above the spec. So I am a bit concerned on what's going on here. I've also measured the ring gap on the second engine that I have, the donor engine, and that engine has 130,000 kilometers on the clock, so 85 less than the engine I'm rebuilding right now. And the gap came out exactly the same. So the top piston ring has 0.25 and the second piston ring has 0.45, so still out of spec. And I kind of think this could be normal for these N42, N43, N46 engines. So the top ring is within spec, but the bottom one is a bit out. I don't think that's too big of a deal. I'm only trying to get another 150,000 kilometers out of this engine. So I am going to reuse the piston rings. If I am making a huge mistake with that, let me know down in the comment section and I'll be glad to listen to you. I've also tried measuring the side clearance on the rings. So this is the clearance between the ring and the piston channel. So this is a bit tighter. It goes from 0.02 to 0.06 on the first piston ring, and on the second ring it is 0.01 to 0.006. And I only have this filler gauge. This is the 0.05, and I am unable to insert it anywhere in the gap. So I'm pretty sure that this side clearance is not out of spec. I'm ready to do the final assembly of the piston. So I've cleaned all of the piston ring channels. I've also made sure that the holes for the oil scraper rings are nice and clean. So this is now ready. I've also cleaned out the old piston rings, and I've made sure that I kept them in the same orientation and order than when I took them off. And I'm first going to use some oil and lube up the piston channels. Then I'm going to start with the middle bit of the third piston ring. So let me just load it. Now I'm going to insert the bottom ring. Okay, it's in. Now the top piece. Now comes the second ring, and this ring has to be oriented correctly. This is a special ring that scrapes the oil out of the cylinder walls. There is a small cut underneath, and that scrapes the oil. So if you turn it around, it's actually going to pump oil up, and you're gonna have quite a lot of oil consumption. So make sure that you orient it correctly. So let's load it in. And now finally the top ring, and this ring has a marking on the top, so you know how to orient it. And it's in. Now I'm going to remove the gudgeon pin again. Sometimes it gets a bit stuck, so I'm going to give it a little bit of the hammer. Now let's insert the conrod, and orientation of the conrod is not important, it could be either way. What is important is to make it the same on all pistons. Let me clarify which markings I mean. I mean the two letter markings on the side of the conrod assemblies, so you can see that there are two letters on each part, they have to match. And don't look at the markings that are stamped on the part itself, because they're not the same on all conrods. So one may be oriented like this and the other is gonna have the markings on the other side. So when you are assembling all of the pistons and conrods, make sure that the direction of the pistons coincide with the markings on the conrods. There is a marking here on the top of the piston. There's an arrow, and this arrow always points towards the front of the engine. Now I'm able to press the pin in, and let's check if everything looks okay. There is not excessive amount of play here. There is a little bit, but I don't think it's anything too alarming. It's normal for this conrod to float, but if you have too much play here, then you should consider replacing the whole assembly, conrods and the pistons and the gudgeon pins. And the gudgeon pins come mated with the pistons, so you cannot switch the pins from another piston. So just keep that in mind. Now I have to put back the circlip, and I'm going to put it in this orientation so that the two ends meet at the top. It doesn't really matter how you do it, just do it the same on all of the pistons. So I'm going to load the top part first, and I'm going to try and be careful not to scratch anything. and then I'm going to use the same screwdriver and try and pry it together. So I'm pretty close now, and it's in. Try to be careful not to scratch the piston, but to be honest, it's kind of hard to avoid. Now I'm going to inspect both of the circlips and make sure that both of them are seated all the way in, because if they're not, well, it's gonna be a huge problem. Now I'm going to check the play of the gudgeon pin, and yeah, I'm just about able to slide it back and forth, and that is the correct tolerance. If you are unable to slide it, that means that there's something wrong. Maybe the pistons hit the valves and the piston is now bent, and that's why the pin cannot float correctly. If you have to use a lot of force to drive this pin out, that could mean that there are some issues with that piston. But this one, luckily, feels just fine. So this is the first assembly: conrod, piston and piston rings. Now I just have to do the same for the rest of the pistons. Now I can remove the rest of the attached parts, like the belt tensioner and the sensors. These two check valves that are sandwiched between the cylinder head and the engine block prevent the oil from draining back into the oil pan from the VANOS system. So on the next startup you have a nice, clean, rattle-free startup because the oil is still in the system. I'm going to remove the check valves and inspect it. They can get damaged or clogged, so I guess we're going to see in what kind of condition they are. I have to be careful not to damage anything because it has to make a good seal here. So these are just the spacers. Let's see how the check valve looks like. So it's a really simple design, just a spring and the metal ball, and the spring pushes the ball and the valve closes, and when the oil pressure is applied it opens up. So let's see if it works. I'm going to spray just a little bit of brake clean in and see if the brake clean comes out on the other side. It looks like it holds the fluid, so let me open it, and it drains. So I think I can reuse this, but if they are cheap, I'm going to replace them. After cleaning the valves, I did in fact find some copper shavings from the bearings, so yeah, that was definitely a good idea to clean them out. With the valves removed, I can now proceed to cleaning the engine block surface. I've already cleaned this part here and it came out quite nice. To clean this, I first used some WD-40 and I sprayed it on the surface. Then I used a scraper and just gently scraped off all of the excess material from the head gasket. And you have to make sure that the scraper is always nicely lubricated so that it glides and it just takes off the heavy deposits of the head gasket. You have to make sure that the scraper runs parallel to two surfaces so it doesn't cut into the aluminum, and this way it's gonna remove the top part of the head gasket like this, and you have to go slowly and take your time, and it should work just fine. After the scraping, I use Scotch-Brite pads and polish the deck by hand. This takes some time, but the final result is a pretty smooth surface, and that's what you want for the head gasket to make a good seal on the engine block. I'm going to use earplugs and plug the oil lines so I don't introduce any debris inside of the oil channels. I'm also going to use some Scotch-Brite and clean the carbon deposits from the top of the cylinder walls. Now I have to remove the upper bearings on the main journals. And with that, I'm now ready to clean the block, and I'm going to use a pressure washer, and I'm just gonna rinse the block a little bit so that the major deposits fall off. Here's the block after the washing with the pressure washer. Now I have to dry the cylinders so they don't rust. Now I'm using a little bit of multi-purpose degreaser and a toothbrush, and I just went around and cleaned all of the surfaces. So it's getting nice and clean. The engine block is back on the engine stand, and once again I use some Scotch-Brite pads and clean the surface so it's nice and smooth. Now I have to make sure that the threads for the main bolts that hold the lower crankrace to the engine block are nice and clean, so I'm going to use this bit and just chase the threads, and I'm going to do this by hand because I don't want to cross thread this bit. And I'm going to go all the way until I feel that it's at the end of the bore. Here it is. And there is a little bit of debris here, but nothing too major. Now I just have to do the same thing for all of the journals. Now I have to remove the oil spray nozzles. These nozzles spray oil onto the pistons and onto the cylinder walls, so that keeps everything cooled and lubricated. It's important to clean these nozzles because they can get clogged with debris, and also inside of these bolts there's a check valve, and that can get clogged too. I already removed one of the nozzles and I can already see that there is quite a lot of debris inside, so I will definitely have to clean this out. The orientation of these nozzles is very important to get the correct spray pattern, and when you are reinstalling it you have to put it in the same orientation. And there's a special tool that aligns the nozzles, however obviously I don't have that tool, so I just have to mark this orientation in a different way. So what I'm going to do is I'm going to be a bit brutal and just use my knife and just follow the line of the nozzle, and I'm going to mark it on the block. I'm just gonna make very shallow cuts, and these are gonna be my marks, so when I reinstall this it's going to be in the same orientation. Yeah, there's quite a lot of dirt here. And here's the check valve. There's a small ball inside and 4 holes in the bolt. Let's give it a bit of a clean. Let's clean the check valve in the bolt. Here's a great example of what could be lurking inside this check valve. Quite a lot of debris, and check this out. This is a huge chunk. So this can definitely clog up your nozzles. Now I have to clean all of the oil channels, and I'm going to use a lot of brake clean and a small brush, This is actually a brush from a metal straw kit, so this is for cleaning metal straws, but it works very well for this application. I'm going to remove the protective plugs, and this way I can wash out all of the debris. So I'm going to spray the brake cleaner into the passages and then give it a little bit of brushing. And then I'm going to use a small PVC hose and attach the brake cleaner at one side, and I'm going to spray the brake cleaner into the all passages. I'm going to do this for all of the oil passages, and I'm also going to rotate the engine around and spray the brake clean from other directions and orientations, so I can make sure that all of the channels are nice and clean. And I'm going to let the brake clean come out on the other side. I'm also going to clean the surfaces and remove all of the oil residues. Now I can reinstall the nozzles. Now I have to make sure that the nozzle lines up with the marks that I made on the engine block. And finally I have to torque it down to 12 Newton meters. Now I have to prepare the lower crankcase, and I already cleaned it the same way I cleaned the engine block. And now I am cleaning this sealant channel that goes all around the cradle. And I used some heat gun and I applied some heat, and it mostly just kind of fell out during cleaning. So I used a plastic tool like this. This is a trim remover tool, and I just cleaned the channel like this, and it works pretty well. I still have some minor spots that I have to clean. I use wooden chopsticks and I just apply a little bit of pressure to get that old sealant out, and this way I'm not gonna scratch anything. I'm also going to use the Scotch-Brite pad and the chopstick, and I'm going to polish the channel a little bit and make it nice and smooth. I'm going to remove the plug here. There are two plugs on the side, and this is where the sealant is pressed through the channel. So this has to go out. I'm also going to polish the surface between the main engine block and this crankcase with the Scotch-Brite pad and make it nice and smooth. Now I have to make sure that the donor crankshaft will fit into the engine block. There is a 5-letter code on the side of the engine block, and that corresponds to the clearances on the bearing journals. So the first letter means the first bearing, and the 5th letter means the last 5th journal. There are also marks on the crankshaft. It's kind of hard to show you, but there's a code engraved in this area, and this code signifies the construction stage of the crankshaft, so the grounding stage on the main bearings and on the conrods, and also the tolerances for each of the bearing. In my case, I have the letters B, 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 C and B on the engine block, and on the crankshaft I have a marking of AA, ES, 11, 21, 31, 41 and 51. The first letter A signifies the original dimension on the conrods, and the second A signifies the original dimension on the mains, and ES means the factory production run, I think. And then I have the numbers, and the first number means the bearing number 1, and the second number right after it means the tolerance. So the first bearing has a tolerance 1, the second bearing has a tolerance 1, the third bearing has the tolerance 1, the fourth bearing has the 1 tolerance, and also the fifth bearing has the tolerance range of 1. Okay, but what does that mean? Okay, now let's decode this. So the letter A means yellow, the B means green, and the C means red. And if you have the number, the 1 means yellow, 2 means green, and the 3 means red. And after you decode this, you get color combinations for the bearings on each of the location, and you have to combine this to get the correct tolerance. However, there is one exception. If you get the combination yellow plus red, it is not allowed, so you have to use green and green So that means you have to decode the letters on the block and numbers on the crankshaft into a color combinations for each of the bearing positions, and then you have to run to the BMW dealer and order the correct parts. And of course that all costs money, and I'm really trying to do this rebuild on a reasonable budget, so I went ahead and ordered the standard set of Mahle bearings. They are not color coded, so the plan is to use plastic gauge and just make sure that each of the bearing position is within spec, and if I find the position that is out of spec, then I can go ahead and order the correct set of color-coded bearings. So first I have to make sure that all of the surfaces are totally clean, so no residue of oil or dirt. I also have to make sure that all of the journals on the new donor crankshaft are nice and clean. I really don't like how these bearing shells are packed. I already scratched one of the bearings a little bit, so be careful when taking them out. Now I can start putting in the top bearing first, and have to put the bearing shells with the oil groove in this location, so in the engine block. And of course I also have to make sure that the tang engages with the slot. Number 4 is a thrust bearing, and the number 5 bearing. I have to make sure that all of the bearings are all the way in and centered. Now I have to load the bearings into the cradle. Now I have to put in the crankshaft and be careful not to scratch anything. And I must not rotate it. I've cut the plastic gauge strip into 5 parts, approximately the width of a bearing shell. I've put the strips of plastic gauge at a 90-degree angle, so at the top of each of the journals. Now I have to put on the cradle, and I have to be very careful not to disturb the plastic gauge. Now I'm going to reinstall the old bolts. I've cleaned them and oiled them a little bit. Now I have to torque them to 20 Newton meters. And now I have to do 70 degrees of rotation on each bolt. So I have my angle gauge here. And I have to repeat this for all of the bolts, of course. All bolts are torqued. Now I can remove them. Okay, let's check the clearances. So the clearances on the mains have to be between 0.030 and 0.070. I have the measuring strip for the plastic gauge here, and that means that the markings should be between this size here and this size here. So let's check it. The first journal is probably around 0.045, something like that. So definitely well within the spec. The second journal seems to be around 0.038. So it's right on the mark, so a bit tighter here. Number 3 bearing also seems to be on this mark, so the tolerance is 0.038, something like that. Number 3 bearing is approximately 0.038. Here's the fourth journal, 0.038. And if you remember, this one is a bit special. So this one has the letter C, and the last bearing is between 0.05 and 0.038. So I think this one is about 0.045, something like that. So bearings 1 and 5 are slightly looser than 2, 3 and 4, but still well within the spec. I think that these clearances should be okay for this rebuild. Now again, I'm not building a new engine, I'm not building a very powerful engine. This is just a very basic engine, so I don't expect to see a lot of load here. So I think it's gonna be just fine. Now I'm going to remove the crankshaft and clean the plastic gauge. I'm also going to clean the plastic gauge from the bearings. Now I'm going to apply a little bit of oil onto the bearings, and I will be using a 5W40 oil for this. It is a bit thicker, so it's better for assembly. I've cleaned my finger from previous rectal exams, and I'm going to smear the oil on the bearings. I'm also going to clean the channels on the crankshaft. Now I have to clean all of the surfaces for the bearing journals, so I'm going to use brake clean again. Ideally I would do this with the lint-free towels, but I don't have them, so I just have to make do with what I have. And basically I just have to make sure I don't leave any major particles there, and I should be fine. Okay, the crankshaft is now ready to be put back into the engine block. I'm going to put some oil on the thrust bearing. And now I can try and rotate it a little bit. I'm also going to clean all of the channels on the cradle and also all of the surfaces. They have to be oil-free. Now I have to apply the sealant inside of the channel, and I will be using the prescribed Loctite SI5970. So this is the special flange sealant. It comes in a smaller 50 milliliter cartridge, so I had to adapt a normal cartridge gun. So what I did is I removed the nut and the bigger flange from this shaft and 3D printed a smaller adapter here that fits into this cartridge. So I can now fill the cartridge in. Now I need to apply nice and even bead and not too thick. There is already oil on the bearings because I rotated the crankshaft, so now I can just mount the cradle. And now I have to install new main bolts. They are new from BMW. You have to replace them because they are stretched to yield. I'm gonna oil the bolts a little bit. They have to be oiled to be torqued correctly. Now I'm going to drive them in. Now I'm going to torque them to 20 Newton meters. Now I'm going to mark all of the bolts to make sure that I don't miss anyone in the next step. Before I do the final torquing, I want to make sure that the crankshaft can rotate. And it looks like it can rotate just fine. And once again, I have to rotate them 70 degrees. One done, 9 to go. Now I have to reinstall the rest of the bolts on the cradle. So there are 13mm bolts here, and these two bolts are slightly longer, so make sure you put them back correctly. And also here at the front, these two bolts are longer than the rest of the outside bolts. I'm going to start all of the bolts by hand, so I make sure that the thread engages with the block. And finally, I have to torque all of the bolts to 22 Newton meters. Now I'm going to reinstall the plugs. I have to remove the excess amount of sealant. Now I have to load the bearing shells into the conrods. First, I'm going to clean the surfaces. I'm also going to clean the surfaces where the conrods are cracked. Now I can load the bearing shell onto the conrod. And I have to make sure that the tang engages with the slot. I'm also going to load the bearing shell into the conrod cap. I have to make sure that it's pressed in all the way. Repeat the process 3 more times. Here I have a set of fresh new conrod bolts from BMW, and before installation I have to oil them up a little bit. Now I'm going to do the final cleaning of the bores, and I want to do that in horizontal position so that I don't introduce any new dirt onto the crankshaft. Now I'm going to apply fresh oil on the cylinder walls. Now I can finally start loading the pistons, and to do that I have to compress the piston rings, and there are several ways to do it. There are some generic piston ring compressors, but I chose to go my own way as usual. I've designed and 3D printed this plastic ring compressor. So this is basically just a cylinder with a slight taper, and this taper compresses the rings while the piston is pressed in. And it's not perfect, so I did have to do some testing, and I did have to sand it down a little bit with a fine grit sandpaper to remove the layer lines. But after the sanding, this is what I am left with. So when I applied some oil and tested this design out, it worked pretty well. I've made sure that the orientation of the crankshaft is such that the pin is all the way at the bottom. So first I'm going to oil up the ring compressor. Now I can put it over the cylinder. I'm also going to oil up the piston rings and the piston. I'm also going to oil up the skirt of the piston. Now I have to make sure that the piston ring gaps are oriented correctly, so they have to be spaced apart by 120 degrees, and the gap must not be over the gudgeon pin. The orientation is only important during installation and on the first startup, but after the engine runs, the piston rings are gonna rotate around, or at least they should, and the orientation doesn't really matter. So I have the bottom ring gap here at this hole, and then the second ring has a gap on the other side, on this hole, and the top ring has a gap right at the arrow. So this is approximately 120 degrees. Okay, let's load the piston. And again, this arrow must always point towards the front of the engine. Now I can just gently press it in. And it's in. It works. Now I'm going to rotate the engine 90 degrees. Now I'm going to push the piston in from one side, and from this side I'm going to align the conrod. And of course I have to make sure that it is rotated correctly. I'm going to apply some oil on the bearing. And of course my finger is clean. And now I can install the shell. Now I just have to make sure that the cap sits perfectly on the rod. I'm going to make it hand tight. And I'm also going to apply a little bit of oil on the sides. Let's do piston number 4 next. Arrow pointing towards the front. All of the piston rings are oriented correctly. Let's load it. Now I'm going to rotate the crankshaft 180 degrees. Now I have to torque the conrod bolts to 20 Newton meters. Now I have to rotate the bolts 120 degrees, so first I'm just going to mark the center line. This way I can be sure that I've actually torqued the bolt correctly. I was planning to use my angle gauge here, however, when I've assembled everything together, I realized that it was kind of wobbly and inaccurate. That's because I have a E10 socket that is 3/8, and then I have to adapt to 1/2 inch. And if I try to engage this angle gauge with this tip here, there's like no realistic way to do this accurately. Angle gauges with magnetic holder seems to be a better option here. I did notice that the bolts have 3 marks that are evenly spaced, and knowing the German engineering, you can be pretty sure that this is 120 degrees between each mark. So that means that if I just make a mark on the cup and rotate the bolt to the other mark, I should have exactly 120 degrees of rotation. So what I'm going to do is use my knife and make a very shallow, very tiny mark on the cup, and I'm going to make the mark right next to the mark on the bolt. And this shouldn't really hurt anything. I know that it's a really tiny mark, but I can just about see it. I'm also going to do the same on the other side. Okay, that should be enough. You can see that that worked pretty well. These two worked pretty well. Conrod bolts on number 1 are done. I just have to do the rest of the bolts. Well, I think I'm done with the hardest part of this bottom end rebuild. Now I just have to assemble the rest of the parts onto the block. Now I have to reassemble the oil pump, and I cleaned all of the parts as much as I can. So I'm just gonna put in some fresh oil. I'm gonna make sure that everything is lubricated. Now I have to install the rotor, and I have to make sure that all of the vanes are in the exact same position. I'm going to clean the excess oil from the surface. Now I'm going to install the shaft. And now I'm going to put the two halves together. Now I'm going to install back the bolts. I couldn't find any official specification for the torquing values for the bolts. That's because the unit is not serviceable. However, usually these M6 bolts into aluminum are torqued to 10 Newton meters, so that's what I'm going to do. Now I want to make sure that the shaft spins freely. And it does, and it feels nice and smooth. Now I can reinstall the balancing shafts unit, and I've cleaned it the best I could. So I used some gasoline, some brake clean, and then I pumped oil in all of the oil channels, and I think this will work. There are a couple of dowels here that have to engage. Before installing the bolts on the unit, I have to install the oil pump, and that's because this can only be removed as a single unit and installed as a single unit. This little part here catches on the block and it cannot be removed or installed, so I have to do it now. Now I can install the bolts. These bolts have to be replaced. They are stretched to yield and they have to be lubricated before installing. Before torquing down the balancing shaft unit bolts, I'm going to first install and torque the bolts on the oil pump. The two longer bolts are at the top, and this slightly shorter one is at the back, and this one is at the front. And they have to be torqued to 10 Newton meters. And now I can install the bolts that hold the oil pump to the engine block, but I'm not going to torque them down just yet. This one goes to the back. Now I can start torquing the bolts. So these 6 bolts have to be torqued to 25 Newton meters. And then they have to be rotated for 90 degrees. So I will have to mark them. I could use this angle gauge, but this is not the best option because it's not very precise in this orientation. So I'm just going to rotate them by hand and just observe the markings. And the 3 M8 bolts for the oil pump have to be torqued to 25 Newton meters. Now I'm going to rotate the balancing shafts and check if they spin freely. And they do, so this is a good installation. Now I'm going to assemble the chain drive for the oil pump. So I'm going to start with the tensioner, and I'm going to install the spring and put some oil inside. And then I'm going to install the piston. Again, I'm going to put some oil on the surface. And I'm going to close it off with this slide. And it makes funny noises. Nice. And then I'm going to lock everything with the pin provided in the timing kit. Now I can install it onto the slide rail. You can see that there's a special shape here that you have to match. And then you can press in the tensioner and rotate it. Now I have to push the locking pin out of the way. And on this side it locks in place. Now I can load the sprockets into the chain. The markings on the sprocket have to face forward, so front of the engine. And on the main sprocket, this lip has to face forward. Now I can load it into the slide rail. And I have to make sure that the main sprocket engages with the slot on this plastic rail. And the pump side should just lock in like this. There's a plastic tab here that locks this sprocket in place. Now I can insert the whole assembly into the engine block. And there's a small pin on the oil pump here. And this pin engages with this upper hole. Now I'm going to use one of the bolts to secure the rail. Now I have to make sure that the teeth on this sprocket engage with the shaft on the oil pump. So I just have to rotate it a little bit and it should slide right in. And now I can install the counter-rotating nut. Now I can install the other bolt here. I have to remove this plug here on the cradle and install this bolt here. All 3 bolts have to be torqued to 9 Newton meters. Plug goes back and it has to be torqued to 25 Newton meters. Now I have to torque this oil pump nut to 32 Newton meters, and to prevent the shaft from rotating, I'm going to use this locking tool for the balancing shafts. First I'm going to rotate the balancing shafts like this, and then I'm going to install the tool. Unfortunately, my torque wrench doesn't have reverse setting, so I can only use it in one direction. And so what I did is I've set it to 31 Newton meters, and then I kept on rotating and tightening the bolt until I could no longer undo it with the 31 Newton meters of torque. And then I gave it a little bit more than that. I have it set to 32 Newton meters, and if I try to undo the bolt, it should click. And I think this should work fine. And finally, I can remove the locking pin on the tensioner, and I'm done with the oil pump chain drive. And I'm finally done with the bottom end rebuild. Now that was a lot of work, but in my next video I'm going to be rebuilding the cylinder head, and I have to polish the camshafts and polish the camshaft bearing shells. I also have to lap the valves, I have to clean the lifters, replace the valve stem seals, and make sure that everything checks out, and I also have to do a massive cleanup job once again. And in the final video in this rebuild series, I'm going to reinstall the cylinder head back onto the engine. I'm also going to install the chain and do the timing. Then I'm going to reinstall the oil pickup and all of the auxiliaries on the engine block, like mounts, tensioners, oil filter housing, and the EGR valve and all of the sensors. And then I'm going to finish up by reinstalling the valve cover, the high pressure fuel pump, and the fuel lines. Anyway, thanks for watching, consider subscribing or liking, keep zen, and continue the art of BMW maintenance.